Hi y'all, I'm going to be doing a couple of videos for you since I can't come to school. Please bear with me. I know that my voice sounds really bad and I'm going to cough a lot throughout the course of the video. So I know it's gross and nasty, but please just stick with me. So Miss Lloyd told me that she subbed for me for some of my pre-cal classes and y'all were struggling with this. So you might already have the notes written down. That's okay. I just want you to kind of follow along with me so that way you know what's going on when I get back. So the first example is finding the roots of a polynomial. So first step in finding roots is trying your best to factor what's there. So I'm going to draw the I. A times C goes at the top and B goes on the bottom. So A is 6, B is 1, and C is -2. So A times C would be 6 times -2, which is -12, and B is +1. So I need two numbers that multiply to give me -12 and add or subtract to give me 1. Those two numbers are -3 and 4. I'm going to do this with double distribution. If you want to do it with the box method, that's fine too. So double distribution means that you split the middle term into the two numbers that you found in your I and put an X on them. So I'm going to break this out into -3x plus 4x, and then bring down the terms that were in the front and the back. Then you're going to split it into two groups of 2 and take out the GCF on both of those groups. So between the 6x squared and the -3x, my GCF is 3x. 6x squared divided by 3x is 2x. And -3x divided by 3x is -1. On the other side, between the 4x and the -2, the largest number that you can take from both is a 2. 4x divided by 2 is 2x, and -2 divided by 2 is -1. So we know we've done this correctly because these terms are matching. So the matching term is one of the factors. The other factor are the two GCFs that you took out. Okay, so that's my factored form. Then I'm going to take those factors and set them equal to 0 to solve for x. So you have 2x minus 1. And then you're going to solve for x on both sides. Okay, so we have two roots of our polynomial. The rest of this is just fancy definitions. The big formula that I want you to get out of this is this. So this formula tells you where the possible roots of the polynomial are. So it doesn't mean that those are guaranteed to be the roots. It's just going to help us generate a list of what the possible roots could be. Okay, so I'm going to start making the list. So P and Q are the first and the last number that you see. So the last number that you see, that 20, that's P. And the first number you see, the 8, that's Q. So you're not going to like straight up divide these. You're going to list out the factors of these numbers. So you're going to list out all of the things that you can multiply together to get to 20 and to get to 8. So I'm always going to keep that plus and minus sign that applies to every single one of those numbers there. So if you have, like on the bottom, we have 1, 2, 3, 4 numbers, you really have 8 because you're taking the positive and the negative version of that number. So on my key, I made a little chart just to help you like organizational wise what the numbers are. So these are going to be fractions. So the numbers that I'm going to put up here are going to be the top numbers of the fractions or the numerator. And then the numbers on the side are going to be the bottom numbers or the denominator. So on the top, I'm going to list the top numbers from this fraction. So all of these numbers here are going to go at the top of the chart up here. Okay, and then all of the bottom numbers, so all of the numbers from here, are going to go on the side of your chart. And then I'm going to just draw lines to separate them. Okay. So now I'm going to start dividing. So I'm going to take the top divided by the bottom. So first step, I'm going to do 1 divided by 1, and you're going to keep the plus minus in front of it. Then you're going to go to the next number on the top. So plus or minus 2 divided by 1. 2 over 1 is 2. Plus or minus 4 divided by 1 is 4, and so on. Okay. And then you're going to continue with the top number, and you're going to change the bottom number. So now I'm going to still focus on the 1, but I'm going to pair it with that plus or minus 2 that's there now. So you're going to have 1 divided by 2, which is a half. 1 divided by 4 is 1/4. 1 divided by 8 is 1 over 8. Okay, then you're going to keep doing this. If you get a repeating number, you don't have to list it twice. So for example, if I go and I try to do plus or minus 2 from the top and plus or minus 2 from the bottom, 2 divided by 2 is 1, but I already have a plus or minus 1 in that very first row and column, so I'm not going to write it again. So that's why on my key, you see that there's blank boxes there. Okay, the next place that I start getting new numbers is when my top number is 5. So we already did the 5 divided by 1 gives us 5. 5 over 2, I can't simplify, so I'm going to leave it as is. 5 over 4, and 5 over 8. Okay, so all the rest of the numbers are going to end up being repetitive, so you don't have to write them out again because we're just looking for the list of possible roots of the polynomial that's listed above. Eventually, you're going to have to check if these roots are actually the roots or not, And we're going to do that using synthetic division. You learned this in Algebra 2, but I'm just going to give you kind of a quick refresher on how to do it. So whatever number you're dividing by, so in this case it's the x plus 2, you're going to take that number and set it equal, or that term expression, and set it equal to 0, and then you're going to solve for x. So I get that x is equal to -2. So I'm going to set up a box like this. That number, the -2, is going to go on the outside here. And then the coefficients of your variables, in order from the ones with the highest exponent to the lowest exponent, are going to go on the top. So this 2 is going to come here. The -5 is going to come here. Notice that I do not have an x squared term, so the coefficient on x squared is 0. The 3 is going to go here, and then -4 goes here. Okay. So the process for this, the first number always gets brought down, and then you're going to multiply the number on the bottom with the number on the side. So you're going to multiply the -2 that I highlighted in green with the blue 2 that's on the bottom. So -2 times 2 is -4. That goes underneath of your next slot, and then you add those two things together. So -5 plus -4 is going to give us a -9, and then I repeat the process. -9 times -2 gives me a positive 18. Then we're going to add going down. 0 plus 18 is 18. Then you're going to multiply 18 times -2 is -36. Add going down. 3 plus -36 is going to give us -33. -33 times -2 is a positive 66. Add going down, and you get 62. The last number that I get, I always like to box it off. That number is the remainder of your division. The other numbers are the coefficients of your quotient of division, and you always go down an exponent. So if I started off with the highest power of a 4, my new quotient has a highest power of a 3. So I'm going to write the variables that go with each of these numbers. C means constant. It means it doesn't have a letter attached to it. So my answer would be like this. And then the way that you might write your remainder is you add the remainder number divided by whatever you divided by here. So you have x plus 2. And that would be your answer. Okay, the next one is the same process. You're going to take the number that you're dividing by and set it equal to 0. Solve for x. And then set up your box so that 3/2 goes out here, and then these numbers go in the top of the box. I don't need any zeros here because I'm not missing any terms. And then the process follows. If you want to use your calculator to multiply the fractions, it's fine. So you're going to do 4 times 3/2 gives you 12 over 2, which is 6. And then add going down. Then you're going to do 2 times 3 over 2. 2's cancel, and you're left with 3. Add going down. 0 times anything is 0. Add going down. Negative 2 times 3 over 2. Negative 3. Add going down. And then 3 over 2 times 2 gives us 3. Add going down. So in this example, you're left with the remainder of 0. So again, you're going to go down an exponent. Since my highest exponent here was 5, the highest exponent on my answer is going to be a 4. I don't have to write the remainder since it's just 0. And to simplify it even further, you don't have to write the plus 0x squared. Okay, so that would be your answer. So this is going to be our method for checking if a polynomial has that as a root or not. Okay, then this next one, first thing, we're going to use rational root theorem, and we're going to generate our list of roots. So negative 8 is P, and 6 is Q. It doesn't matter what sign is in front of the number because you already have a plus minus sign in the formula that takes care of everything. So now on the top, I'm going to list all the factors of 8. And on the bottom, I'm going to list all the factors of 6. And then I'm going to draw a box to help me keep those organized as I do the division. Remember that these are the top numbers of your fraction, and the side is the bottom of your fraction. Okay. Then I'm going to do the division. So I'm going to start with the first row and the first column. So 1 divided by 1 is 1. 2 over 1 is 1. 4 over 1 is 1. 8 over 1 is 1. Or sorry, I don't know why I keep saying 1. 2 over 2 over 1 is 2. 4 over 1 is 4. 8 over 1 is 8. Sorry. Okay. And then I'm going to go down the first column and then the rows. So 1 divided by 2 is a half. 1 over 3 is 1/3. And then 1 over 6. Okay. Then if you do 2 divided by 2 or 4 over 2 or 8 over 2, you're going to end up getting numbers that we already have. So I'm going to skip down to combining the plus or minus 2 on the top with the plus or minus 3 on the bottom. Okay, so there we have our list of potential roots. So in total, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, doubled because of plus and minus. So we have 20 potential roots, and we want to figure out if they are actually roots or not. The way that you do that is using synthetic division. I'm not going to torture you and make you do all 20 of them. I'm just going to ask you to test a couple of them to tell me if they're roots or not. So in this case, just so things work out the way that they're supposed to, we're going to test x equals 1, so positive 1, and x equals negative 2. So we're going to do synthetic division with the expression that's up here, and then the two roots that I'm asking you to test down here. Okay, so you're going to have like two separate synthetic division problems. So first thing I'm going to test is x equals 1. So that means on the outside of my box I'm going to put 1, and then I'm going to put all of my coefficients. And remember, I'm using the equation highlighted up there. Okay, and then I'm going to start my synthetic division. Okay, so my original problem had the highest exponent of a 4, so my answer is going to have the highest exponent of a 3. Okay. What it means when you get a remainder of 0, according to the rational root theorem, is that the number that you've tested is a root. So if you get a remainder of 0, it is a root. If you get a remainder of anything other than 0, it's not a root. So okay, so it's a root, and that the factor version of it is a factor. So next I need to test the x equals negative 2. To make my life easier, I'm going to use the answer that I got from the previous synthetic division, so I have less numbers to deal with, and you can do that, that's fine. So I'm testing negative 2, and then I'm going to bring down these numbers. Okay, bring down your first number. And we get 0 again. So that means, since I have a 0 remainder, that x equals negative 2 is a root of my polynomial. I'm going to stop there for today, and then I'll post the video that includes the little chunk of the notes that's left. I'll post that tomorrow, and you guys can work on that tomorrow. But for today, just make sure you get this video's content in your notes. Tomorrow, you'll finish up that last little bit of the notes from like 3, 4, and 5 of what's left, and then you're going to get a practice assignment that goes with that. I'm sorry for my disgusting coughing, and I will try to get back to you as soon as possible.